In this presentation, we will be discussing bacterial toxins, which are harmful substances produced by bacteria. These toxins play a critical role in bacterial pathogenicity, causing disease and foodborne illness worldwide. Understanding bacterial toxins is essential for preventing foodborne outbreaks, improving food safety, and protecting public health. There are two main types of bacterial toxin, which is exotoxin and endotoxin. For detail, my friend will explain in other slide later. Foodborne illness are often caused by bacterial contamination. The four most common bacteria is Salmonella, found in raw meat eat, Escherichia coli, E. coli linked to undercooked beef and contaminated water, Clostridium botulinum, which produce the botulinum toxin in improperly canned. The last one is Listeria monocytogen, found in ready-to-eat food like unpasteurized dairy.
Next, sources of bacterial toxin in industrial contamination. Okay, in industrial setting, bacterial toxin can originate from several key sources. Number one, contaminated raw material like powdered milk or spices may carry bacteria such as Salmonella and Bacillus. Number two, unclean processing equipment, particularly those with biofilm, can harbor Listeria monocytogenes. And number three, inadequate water treatment is another major risk because as non-potable water introduce pathogens like E. coli. Number four, improper waste management can lead to Clostridium perfringens contamination in nearby facilities. And number five, defective packaging materials such as Astra vacuum pack create ideal condition for Clostridium botulinum growth. Next, real-life foodborne outbreak. In 2020, a Salmonella outbreak linked to a contaminated irrigation water in Onion led to 1,200 illnesses across 48 states in the US. And in 2008, Salmonella contamination in melamine-tainted infant formula in China resulted in a tragic impact. 6 infant deaths and 300,000 people are affected. Similarly, in 2018, an E. coli outbreak traced to contaminated water used on ramen lettuce caused 210 illnesses and 5 deaths in the US. This example highlighted the importance of maintaining stringent safety measures across the food supply chain.
So next, we move on to the part mechanism of toxicity of bacterial toxin. So bacterial toxin have diverse and devastating effect on the body, with the mechanism classified into exotoxin and also endotoxin. So exotoxin like botulinum toxin, produced by the Clostridium botulinum, are secreted by bacteria and specifically target the cellular function. For instance, the botulinum toxin and AB exotoxin blocks the nerve signal transmission at synapse, leading to the flaccid paralysis. So in this picture, the patient suffering from the botulism. So this person cannot move his lips and protect his tongue. On the other hand, endotoxins such as LPS, lipopolysaccharide from the gram-negative bacteria act differently. When bacteria break down, endotoxins are released into the bloodstream, triggering the host immune system. So immune cells like macrophage detect the endotoxin through the receptor such as TLR4, leading to the release of cytokine like IL-1. So while this immune response aims to protect, excessive cytokine release can result in systemic inflammation, fever, and in severe cases, a cytokine storm causing septic shock or multi-organ failure. Thus, bacterial toxin mechanism is by either targeting the cell directly or overstimulating the immune system, so it shows their critical role in the bacterial pathogenesis.
Next, I will continue discussing on the key symptoms of bacterial toxicity that affects our bodies. These symptoms can be categorized into three main types. The first one is gastrointestinal symptoms such as nausea, vomiting, and diarrhea, often point to issue in the digestive system caused by food poisoning, infections, or toxins. The second point is neurological symptoms, include signs affecting the brain, spinal cords, and nerves, such as headaches or paralysis, which may be linked to toxins or infections. The third one is systemic symptoms, involve the whole body and can include fever, chills, and fatigue. These symptoms suggest a widespread response to infections or toxins. The severity of these symptoms can vary depending on the factors like the dose of toxins, types of toxins, and durations exposure. For example, botulinum toxins in high doses can cause several neurological issues like paralysis and death, while in lower doses, it may only cause mild symptoms such as blurred visions and difficulty swallowing. Certain groups like elderly, children, and immunocompromised individuals are at higher risk for more severe symptoms. This population should be especially vigilant when exposed to toxic bacteria.
The last part is the preventive and control measures to minimize the risk of bacterial toxins in food. Firstly, proper food handling and hygiene are essential. Wash hands for at least 20 seconds with soap and warm or cold water before, during, after preparing food and before eating. Store perishable foods at temperature below 4 degrees Celsius or above 60 degrees Celsius and avoid cross-contamination. Next, cook food thoroughly, especially red meat, poultry, and eggs to destroy harmful germs. In the food industry, a key method is implementing hazard analysis and critical control points. This helps identify and control hazards at critical points in the production process to ensure that the food we consume is safe. Last but not least, establish a recall and traceability system to track products from raw material to finished products, identify contamination or defects, and efficiently recall affected products to prevent consumer harm. In conclusion, preventing and controlling bacterial toxins require a combination of safe food handling practices, proper cooking, and strict control measures in the food industry. By following this guideline, we can protect ourselves and ensure the safety of the food we eat. That's all from us. Thank you.